loiter mode, altitude hold mode, loiter mode, stabilize mode.
Hello, I'm going to show you how to use all 6 APM flight modes on a Frsky Taranis. I'm going to go through 3 different ways of doing that, 2 with mixes and 1 using custom switches. The Taranis doesn't have a 6-position switch, so we're going to have to combine 2 switches. I'm going to use one of the 3-position switches to switch between 3 different flight modes. We are going to use a second switch to select a different flight mode range, and then our 3-position switch will flick between those 3 different flight modes. So let's get started. Our Taranis and all its channels operates between minus 100% and 100%. It's its way of defining the range. In RC PWM, pulse width modulation, the width of the pulse goes from 1 millisecond, that's 1000 microseconds, to 2 milliseconds or 2000 microseconds. That is equivalent to the minus 100% for 1 microsecond to plus 100%, it's 2 microseconds. Our 3-position switch that we're going to use goes from minus 100 or 1 microsecond to 0 in the middle, or 1.5 microseconds, to plus 100, which will be our 2 microseconds. This table looks quite confusing, but it is, I'm going to take you through it, so it will be fairly self-evident at the end. The first 3 columns define our flight modes and the width of the pulse in microseconds to indicate that flight mode. So anything less than 1230 microseconds will be taken as flight mode 1. Anything between 1231 microseconds and 1360 microseconds will be flight mode 2, etc. In the middle column, I have put in what our minimum actually is, taken from Mission Planner, from our Taranis, 991 microseconds. If we use the default of 1000 microseconds, 1 millisecond, that should be sufficient. Similarly, my Taranis is giving 2014 microseconds as its maximum pulse, but if we took 2000, we'd be in the same ballpark. The calculated columns are giving us the minimum and maximum microsecond values from the APM documentation in Taranis speak. What I am doing is I am taking the value and converting it into a percentage. So that's a microsecond value into a Taranis percentage. So 991 would be equivalent to minus 100. 2014 would be equivalent to plus 100. So the way I'm doing this is I'm taking the APM documentation value, I'm subtracting the minimum that I'm getting from my Taranis, so I could use the 1000. I am taking the maximum, subtracting the minimum from it, and dividing the 2. So, although it's shown below the table, if I take as an example, I'm taking the 1230, I'm subtracting 991 from it. I'm dividing that by my 2014 minus 991. That will give me a percentage from 0 to 1, but I need it from minus 100 to plus 100, so I need to multiply that by 200. That will give me 0 to 200, and subtract 100 from that, which will then give me minus 100 to plus 100. Of course, if I was using 1,000 and 2,000, it'd be a lot easier. If I go to my 1,230 and I'm subtracting my 1,000 minimum, I get 230. I'm then dividing the 230 by my 2,000 minus 1,000, which would be 1,000. 230 divided by 1,000 will give me 0.23, and then multiplying that by 200, which will give me 0.43, and then subtracting 100 from that, which will give me minus 57, roughly. So I'm going through each of the APM documentation microsecond values and getting the percentage. Then in the final column, what I'm doing is I'm selecting the percentage I'm actually going to program into the Taranis. I have evenly distributed these about 0, such that the percentage value falls within the range that is expected for that flight mode. So I've chosen minus 60%, which is 24 away from minus 36%, which is 24 away from minus 12%, which is 24 away from plus 12%, etc. And each of those percentages falls within the range, the calculated range necessary to flick it into that flight mode. So looking at it in a line, I've got minus 60, minus 36, minus 12, plus 36, plus 60. That's equivalent to flight mode 1, minus 60, through to flight mode 6, plus 60. So our 3-position switch gives us minus 100 to plus 100 currently, but we only want it to give minus 60 to plus 12 in the initial range. So minus 60 to plus 12 is 48%, which is actually 24% of the maximum switch position, the current maximum switch position. So to reduce our minus 100 to plus 100, which is 200%, down to 48%, we have to take only 24% of that. Then, instead of it being centered around 0, as it currently is, we need it shifted to minus 36. I'm going to use switch SG to provide the minus 60, minus 36, minus 12. When switch SD is not down, we're going to use SG to provide the range, minus 60 to minus 12, and SD is going to be our modifier to switch between the two ranges of flight modes. So with SD not down, we want minus 60, minus 36, minus 12, and with SD down, we want plus 12, plus 36, plus 60. The way we will do this, or the difference between the two ranges, is this range is 72 added on to the previous range. So difference, the position that gave us minus 60 originally, we want to give us plus 12. The difference between the two is 72. So let's go on to the Taranis and do this programming. I'm going to use Companion 9X to do the programming of the Taranis because it's simpler to see and it's simpler to program. Here we are in Companion 9X. I've got my Taranis connected to the USB port, and now I'm going to download the model data. Here we are. The trifecta is the model that I'm going to modify, and I go straight into mixes. I have my 3-position switch giving me 3 flight modes currently, as shown in the start of this video, and I want to change this now so that we get a different set of flight modes, flight mode 1, 2, and 3, which is minus 60, minus 36, minus 12, And to do that, we had calculated that we wanted 24% of the range. We had also said that we want to move it down to minus 36, so it instead of being rotating around 0, we want it to rotate around the minus 36. So we need to add an offset to that. The offset is also affected by the weight, so we need to put in a value that when we take 24% of that, we get 36. So if we divide 36 by 0.24, that will give us the correct range, and that gives us 150. But we want it negative 150. And that is the first switch. So if I go on to simulate, the SG in this position, our channel 5 is giving us minus 60 or thereabouts. Put it into the middle position, it is giving us minus 36 or thereabouts. Putting it into a final position, the lower position, is giving us minus 12 or thereabouts. So that gives us our flight mode 1, flight mode 2, flight mode 3. Now we need to add in our SD modifier. So this is dependent on SD, and we want it when SD is in the down position. I can actually change this and just use max, which is probably a better one to use because that always gives us 100%. I'm going to call it modifier, modifier. And we wanted to add 72 onto that, so I'm putting 72 in. Okay. Now when I simulate, let's see, with SD in the up position, we get our minus 60, minus 36, minus 12. With SD in the down position, we have plus 60, plus 36, plus 12. So that gives us our 6 flight mode range. So now we want to write that back to the Taranis. Burn to Taranis. So we'll go back into Mission Planner now and just verify that this has worked. Here we are in Mission Planner again. So I'm going to flick my SG switch on my Taranis to see if I can switch between the first 3 flight modes. So flight mode 2, flight mode 3, flight mode 2, flight mode 1. Now if I flick SD right the way down, I've got flight mode 4 in the middle of flicking SG again, that's flight mode 5, and down again, flight mode 6. So back up. So there we are. We have our 6 flight modes selected. So now we'll go back into Companion 9X and I'll show you the second method of doing this. Back in Companion 9X, I'm reading the model data again. And we're into the trifecta model, going to the mixes. Now this is where we have actually added the 72 onto what is already there provided by SG. The second method, we want to change this multiplex mode to replace. And we're going to use switch SG, which is our flight mode controller. And again, we're setting it to weight 24. And where we had taken away 150, we're now going to add 150. Okay, and when we come in to simulate, we should get exactly the same ranges as we did previously. So a slightly different way of doing exactly the same thing. Now we're going to go on to custom switches. Custom switches work slightly differently. What I'm going to do is I'm going to set up a custom switch for each switch position that I want associated with the flight mode. So flick to custom switches. So function 1, flight mode 1, we are going to have a less than x. So this is actually A, and we want this to be our SG switch. So the value we want SG to be lower than, we put in V2. And I'm going to choose here minus 80. There could be anything that is between 0 and minus 100, but minus 80 seems to be a good one to select. Could be minus 90, minus 95, doesn't really matter. So what we're saying here is when SG has a value of less than minus 80, custom switch 1 will be enabled. But because it's a 3-position switch, we need to add a modifier in here to say, and this is also true. So this is where we put in our SD. If I can find my SD, not SD down. So when SG is less than 80 and SD is not down, then custom switch 1 will be enabled. Next one is modulus. So this is when our switch SG is between a minus and a plus range. So we're going to choose 10 here. So when SG is between minus 10 and plus 10, this will be true. But we also want to add in not SD down as well. And the next one is greater than. I want SG again to be greater than 80. And not SD down. So when SD isn't down and SG is in a position that gives greater than 80%, custom switch 3 will be triggered. Now I want to do exactly the same entries again, but for SD down. So not, get SG, so SG less than minus 80 and SD down. Modulus value of SG between minus 10 and plus 10 and SD down. Value of SG greater than 80 and SD down. So that's our 6 flight modes. I'm going to go and simulate this. So we're not interested in the values in channel 5 yet because we haven't added our mix. We're just interested in these custom switches. So we see that custom switch 1 is enabled in that position. In the middle position for SG, custom switch 2 is enabled, and in the lower position, custom switch 3 is enabled. Then I go on, bring SD down, we've got custom switch 6 is enabled in this position, custom switch 5 in the middle position for SG, custom switch 4. Brilliant. Now let's go and add the mixes that we need. Here I am in the mixes screen. So the first thing I'm going to do is I'm going to delete these mixes. Now I'm going to add a new mix in, which I'm going to call flight mode 1. It's dependent on, well, either CS, because CS1 is going to be 100%. So I can put it at CS1, or I can use max, which is 100%. We want it to give off a value of minus 60 when triggered, and it is dependent on switch CS1. So there's custom switch 1. When we've got custom switch 1, we want minus 60 out. I'm going to put in replace, though for the first one it doesn't matter. For all subsequent ones, we need to put in we need to make sure it is actually replace. So this is flight mode 2. This could be set up to CS2 or max again. We want this to give us minus 36, dependent on switch CS2, and is going to replace whatever value CS1 is giving us. And we go through and add the rest of them. Flight mode. Okay, so we've got our mixes in. I have used the same weightings that we calculated in our spreadsheet, though the advantage of this method is that we can use any weightings that we want. So we could use something that's in the middle of the range. If we look at flight mode 1, we've got minus 100 to minus 53.27. I could use minus 75 rather than minus 60. The other advantage of using this method, and the reason that I'm using this method, is to put sounds on these custom switches. To do that, I go into custom function. I find an unused custom function, and I set it up to trigger on custom switch 1. I select play track, and I select the track I want to play. Now that I have got these set up, I will write them back to the Taranis, and then we can test it.
Altitude hold mode, acro mode, altitude hold mode, stabilize mode, simple stabilize mode, loiter mode, drift mode, loiter mode, simple stabilize mode, altitude hold mode, acro mode.
Now I've got the Taranis programmed. It's into Mission Planner to set up the flight modes to match what I've programmed on the Taranis, and then I'm good to go. Thanks for watching.